With this bell work, we're going to find the equation for this that goes through these 2 points in slope-intercept form. So the first thing we're going to find on this one is the slope. And I'm just going to use the slope formula. Remember that your x is going on the bottom and the y is on the top for each ordered pair. So this first ordered pair, -6, 4, the x is -6 and the y is 4. So I put the x in the bottom, -6, and the y, 4, I put in the top. And then the second ordered pair, 5, -7, x is 5, and then the y is -7. So the x goes in the bottom, that's 5. Y goes on the top, that's the numerator, that's -7. And at this point, I'm just going to put this into the calculator, and then whatever it pulls out of it is going to be the slope. And in this case, it gives me -1. And I can use the n over d button to put this into the calculator exactly the way that it looks. So then I would use slope-intercept form to find the y-intercept, because I just found the m, that's -1, slope, but I need to find the y-intercept. So in this example, I'll use the ordered pair from the blue point where the x is -6. So I replace x with -6, and then the y I'm going to replace with 4. Then I just need to solve this, that's all. So -1 times -6 is 6. The 4 doesn't really change, but this is going to equal 6 plus b. And then, to finish this off, I would just subtract 6 from both sides. And then I have got my b value. 4 minus 6 is -2. 6 is 0 out, just like we wanted. And then we just have b. So, finally, in slope-intercept form, the slope is the coefficient of x, and the y-intercept is just what we add or subtract to the x term. We know the slope is -1, and the y-intercept here is -2. That's it. A little bit of review on this one, but I think it's important because several of you have not finished or passed the mastery quizzes from Unit 3A, which you will need to do in order to pass the class this semester, term. All right, numbers in exponential form. Yeah, we're going to look at powers raised to other powers, which kind of sounds weird, but we'll see those examples. So here's our objective today. I can simplify expressions involving an exponent raised to another exponent. Let's take a minute and copy that down, then we'll talk about it for a second. All right, I think this sounds worse than it is, or at least sometimes we overcomplicate it more than we need to. But what you're going to see is if we look at what we've done in the last unit, you could say you got base 5, and this is something that it gets mixed up with. Okay, so you say base 5. Let's say we got an exponent of 8, and then I'm going to multiply it by the same base 5 here. But this exponent we'll say is 12. So since we're multiplying the same base, we're going to keep it the same 5. But those two exponents of 8 and 12, like this, since we are multiplying the bases, we would add the exponents, which would then make this 5 to the power of 20. All right? Now, we have operated with the exponents with addition. We also did subtraction last time. So usually what comes next is multiplication, which is what's going to happen. But there's a difference in how these look. Okay, so if I looked at a new base, let's say 11, and I had 11, let's say will be to the power of, 7. Now what's going to happen is we're going to take this base and exponent and raise it to a power with parentheses like this. We'll raise this to the power of 6, we'll say, okay? Well, what's going to happen then is now we have a power, what we would say is raised to a power. It's a power of a power. So we're not going to change the base, all right? But we are going to operate with these exponents, 7 and 6. And the rule in this case is, since we are using parentheses like this, we would be multiplying these two together. So then we get 11, same base, but now 7 times 6 there is 42. All right? But again, since we've done a lot of addition of the exponents, a lot of students say, well, 7 plus 6, boom, 13. No, that's way off. It's way off. You got to multiply those exponents. And here's why. And you don't have to do this every time, but in fact, you don't really ever have to do it, but this is why it works. Okay, so you'd have 11 to the power of 7 like this, and that's good. But then what we're going to do is we're going to take that 11 to the power of 7 6 different times. All right? So there's 1, 2, oh, that's not what I want. There we go. 3. 4, 5, and then 2 more, 6, and 7, right? And then we'd say, well, since there's, well, I only need 6 of them. Take that last one back. Well, we're just multiplying these out because we see it's the exponent of 6. That's why I had to list these out 6 times. And then at this point, you could say, well, you got 11 to the power of 7, but you had it 6 times. So 1, 2, 3, 4, 5, 6. And yeah, you could just add these together if you'd like. But even if you add them, whether you multiply them, you still get the same exponent there, 42. All right, so I'm not going to expand these ever again because the rule makes this much more convenient. But yeah, that's with the parentheses. If you have the parentheses, you got to multiply those exponents. And it is possible to have more than one base in the parentheses as well, which we'll go over here in later on in this classwork. All right, so we got these 4 examples. And these ones are pretty direct with the rule we just learned. Here's number 1. And again, we got a 15 base right there. It right now has this exponent of 3. But it's in parentheses. So in relationship to the other exponent of 9, since the base 15 to the power of 3 is in parentheses, we need to multiply these out. Okay? So this does not change the base. It's still base 15. But the new exponent, though, will be 3 times 9, which is 27. And that's all. That's as far as we need to go. 15 to the power of 27 is a ginormous number, so we're not actually going to evaluate that. Or in this one. Now, this is showing 2 sets of parentheses, which is okay, because it's just showing that this base here of -2 is in its own set of parentheses, which we should have negative bases in parentheses. Then we look at the 2 exponents, 5 and 8. So it's a -2 to the power of 5 first, and then on the outside of that parentheses is exponent of 8. But yeah, this set of parentheses indicates that between those 2 exponents, we're going to be multiplying. So we'll keep our base at -2, but we need to multiply the 5 times 8, which is 40. So this is base -2 in parentheses to the power of 40. That's as far as we need to go. And yes, it is okay to have bases that are decimals, because again, we're not really changing the base right now. We're just looking at the base as is, in this case 3.4. But again, on the inside of the parentheses, we got the 17, so it was 3.4 to the power of 17. And then on the outside of the parentheses is an exponent of 4, but because of the parentheses, we're going to be multiplying those 2 exponents. So again, the base will not change. It's still 3.4. But then 17 times 4, 68. There's our answer. Now be careful. Sometimes they put this wording on here, which can be more confusing than it needs to be. I'm just going to cross this garbage out. We don't really need it because we're just simplifying this expression. So the base is going to stay the same, and it is okay for it to be a letter such as S, but the 2 exponents, in this case 17 and 4, since they are separated by parentheses, I will need to multiply these out. So my base S stays the same, but 17 times 4 Yeah, we've seen that one at 68 already. So s to the power of 68, and we're done with this one. So this is the rule. It's called the power rule, okay, for these exponent stuff. If you got the base x to some power in parentheses, as we do in this one, we're not going to change the base, but the exponent m, it'll stay in this operation first, and then the n on the outside, since it is separated by parentheses here, we'll be multiplying those out, okay? Now, of course, the x could be a number, the m and n could be numbers, doesn't matter. But this is just the rule for this, all right? And it's true also, just like I said before, and like we've seen with these operations, right, when we were doing addition and subtraction, it's possible to have many bases on the inside of that parentheses. So in that case, it may look something like this one. We'll still use x and y, I guess. Let's say the x had a power of a, y had a power of b, and all of this was to some power c like this. Well, this would indicate that you'd, again, keep the bases x and y. You take the power of xa, and then multiply it by the exponent on the outside of that parentheses. So that'd be like a times c. But y also, with its exponent b, you'd also multiply it by c. So whatever exponent is on the outside is going to multiply it by all the exponents on the inside, okay? And yes, this would work, since this works with multiplication between these bases, it would work with division between the bases. So if you took a fraction, essentially the same way, let's use different letters though. We'll do g and h. So if you had bases g and h, and these had exponents of, I don't know, let me see, we'll say d and k, I guess. And this was to the power of, I don't know, m-n-o, p. All right? Well, this would be, again, the bases would stay the same, g and h. But the base g would keep that power of d, but you'd have to multiply it by the p on the outside of that parentheses. And the base h would keep that exponent of k, but again, multiply it by the power of p. So it doesn't matter, even if there's multiplication or division inside the parentheses, whatever exponent is on the outside is still going to be multiplied by every one of those exponents on the inside of the parentheses. Now that's only with these two operations, multiplication or division. If it wasn't multiplication or division, we wouldn't be able to do this. That's more of a ninth grade thing though, all right? And keep in mind as well, sometimes, like if right here, if the x to the power of a, if the a right there is a 1, you won't see that, okay? In which case you would have to show that phantom 1. But for now, we'll just keep it as a variable. Now, keep in mind also that on the assignment, it's going to start mixing some of the rules, right? So we've seen addition of the exponents. We've seen subtraction of the exponents. And today, we're going over multiplication of the exponents. So the homework may start combining those rules where you need to actually do more than one operation on the exponents at a time, depending on how it's set up. All right, just look at this. And again, this is a very, very common mistake. It happens way more than it should. But this is a common mistake because a lot of students say, well, look, it's we got used to just adding the exponents, which we shouldn't because of the way this is structured. And so they say, hey, 5 plus 7 is 12. Boom, there's your answer. Nope, that's not the answer. That is not correct. In this one, of course, you'd have to multiply those two, right? You'd say, well, 5 times 7, and then you could have your new exponent right there. So let's change that. 5 times 7 is 35. And that would be correct. This would then be correct, okay? And again, we're multiplying because it's an exponent on the outside of the parentheses there. Yeah, we'll do all 6 of these. So here's number 7. We got two different bases, 11 and 4 on the inside of the parentheses. Now, before I continue though, just like I said on a couple slides ago, is the 11 and 4 on the inside of the parentheses do have exponents of 1 and 1, okay? And then the 9 exponent on the outside is going to be applied to those exponents of 1. So 11 has an exponent of 1, the 4 has an exponent of 1, and since we're dealing with parentheses on this, I'm going to be multiplying each of those exponents by the exponent on the outside the parentheses, which in this case is 9. So the bases don't change, it's still got bases of 11 and 4. But after multiplying these, base 11 has an exponent of 1 times 9, which is 9. And then the base 4 has an exponent of 1 times 9, which is also 9. And now, since we are multiplying bases that are numbers on this one, I'll show the multiplication. And that's the final answer on this one. Again, we do not need to evaluate this. So like if you're doing this by hand, that would work. Right, the assignment will want it like this, but if you did this just by the order of operations, you would say, yeah, you could multiply the 11 by 4 there to get 44, and then you'd have 44 to the power of 9. Which kind of brings up, well, I guess it's kind of the backwards of this rule, but I may be thinking of something else. Yeah, as of right now, though, the assignment would want it more like this. All right, so exercise 8. Here I got bases of 3 and 7. Now on the inside of that parentheses, the 3 has an exponent of 2, and the 7 has an exponent of 4. So with the 5, here on the outside of the parentheses, I'm going to have to multiply the 5 by both exponents. So that'd be 2 times 5 as the exponent of 3, and as the exponent of 4, and at 4 times 5. So I'm not changing the bases, and I keep those the same, 3 and 7. But now I multiply the exponents. Base 3, that's an exponent of 2 times 5, which is 10. And base 7 has exponents of 4 times 5, which is 20. So again, I'll show the multiplication between, and that's my final answer right there. Now this one works a little different because the exponents are different on the inside of the parentheses. So even if you're doing this by hand, you would not say 21 to some power, okay? And again, that's because even on the inside of that parentheses, it's out of order. You got to do the exponents before you would do any multiplication of the bases on that stuff. All right, so bases of 3 and A on this one, and yeah, it's okay for bases to be different types of, well, bases on this one. So yeah, I'm going to keep those bases the same. Got bases of 3 and A. Now the 3 had an exponent of 2 there, and the A has an exponent of 4. But again, this is in parentheses, so I'm going to have to multiply those bases by whatever exponent's on the outside. Both of them. So the 3 is now to the power of 2 times that 5 from the outside, the exponent from the outside. And then the A to the power of 4 is multiplied by the same 5. So we're just going to simplify those exponents, which will then give us the answer. So 2 times 5, that's my exponent for 3, that's 10. And the base A, that's 4 times 5 exponent, which is now 20. I don't need to show the multiplication between these two because they're different types of bases. You're welcome to show that multiplication right there, but I don't. All right, 5 times x, all of that to the power of 7. And yes, some of you know that 5 has an exponent of 1, and x also has an exponent of 1. So I'm going to take my base 5 and base x. I'll show those phantom 1s with those. Yep, these are separated by parentheses here, so I'm going to have to multiply those two exponents by the exponent on the outside, which is 7. Now some of you would have this even without having to show that step with the operation of multiplication there, which is fine. But I'm showing it because some of you may benefit from it. So that's now a new exponent for base 5. 1 times 7 is 7. And then my base x has a new exponent. 1 times 7 is also 7. That's fully simplified right there. And you can show the multiplication between, but it's not required that you do. All right, number 11 has bases of 5, x, and y. Do remember, though, that this exponent of 2 does not apply to the x or the 5. And here's why. is because the 5, x, and y are all separated by multiplication. They just didn't show it. So if you applied this exponent of 2 to the x and 5, you were doing it out of order. You'd have to apply the 2 exponent to the base y first by the order of operations, and then you would do the multiplication on that, okay? So this exponent of 2 only applies to the y. So what's the exponents of 5 and x? Ones. Right there. Now these are separated by that exponent of 7 with parentheses, so we are going to be multiplying those exponents by the exponent on the outside, which is 7. So each one is multiplied by 7. Each of those exponents multiplied by 7. So we're going to keep the bases x, 5x, and y. But the new exponents, I'll start with the 5. That's 1 times 7. Exponent is now 7. The base x has a new exponent. 1 times 7 is 7. And then the base y has a new exponent. 2 times 7, which is 14. There we go. All right. Take 1 minute and see if you can simplify this one using this power of power property or rule that we've gone over. All right. 1 minute, go. All right, this is the answer you should get. A to the power of 8, b to the power of 4, and c to the power of 12. Again, this is how it happens, though. So the bases don't change, a, b, and c here. But we're going to take the exponents of the bases on the inside. A has an exponent of 2, b has an exponent of 1, and c an exponent of 3. And we need to multiply those by the exponent 4 on the outside. And again, we are multiplying these because of the parentheses. So multiplication on these ones. And then we can see 2 times 4 is 8. 1 times 4 is 4. 3 times 4 is 12. Done. I do want to do an example where we got to mix some of the rules, okay? So let me just make up my own, and we'll, I guess, make it a fraction as well. So you may see something like this on the assignment. We'll say that 15 and 5, and we'll use A's and B's on this one. And 9's kind of big. Let's use 3. That's better. Okay, so you'll see stuff like this on the assignment today, even though we just focused on multiplication of the exponents. But again, it's important to know how to combine the rules that we've seen already. In fact, you know what? I'm going to add another one right here, that A. So just by the order of operations, I would say focus on the inside of the parentheses there so we don't get things mixed up. So that means that I would start by just focusing on the coefficients here, 15 and 5, which is just showing it's 15 divided by 5, which is, well, 3. Okay, and again, I'm just operating on the inside that parentheses. But then the A's, what do we got? I got an A to the power of 5 in the numerator, but also another A in the numerator, with another A in the denominator right there. So for this, let's say, let's just focus on the numerator. That has A to the power of 5 and A to the power of 1. That'd be A to the power of 5 and 1, which we would then add because the bases are being multiplied. So then that becomes A to the power of 6. Now there's not really anything to do right now with the base A in the denominator, except now that we've simplified the numerator, we can operate with it, okay? So that'd be A to the power of 6, and then A to the power of 1. Since those are being divided, we would subtract those exponents, and we end with A to the power of 5. So these 5 are in the numerator because there's more A's in the numerator than the denominator. That's one way to look at it. Or if it's positive, it should just be in the numerator. So that's the A's, but what about the B's? I got a B to the power of 4 in the numerator, B to the power of 7 in the denominator. That's just a straight subtraction of the exponents on that one because the bases are being divided. And yes, it's always the numerator exponent subtracting the denominator exponent, which would then make this B to the power of -3. Now what we saw last time is you can change this then into just 1 over b to the power of 3. And we do want just positive exponents on this stuff, okay? So as of right now, I've taken the parentheses and I've simplified the inside. As part of the numerator, we have the 3, and we have the a to the power of 5. Why is the 3 in the numerator? Because it's 15 divided by 5, which is 3. It would be 3 over 1, but I don't really need that phantom 1 in the denominator because I've got this b to the power of 3 here, which I can stick into the denominator right there. Well, what happened to the 1 right here in the numerator? I just made it a phantom 1. I don't really need to show that, okay? And all of that is then to the power of 3. So now I can take this, all 3 of my bases, which is 3, a, and b. All right, and let's look at their exponents. So 3 has an exponent of 1. It's a phantom 1 in the original expression we just wrote. A has a power of 5 and b has a power of 3. But this 3 on the outside of that parentheses, since it is on the outside of parentheses, it will be multiplied by all of the exponents on the inside, like this. Okay? So then I have a new fraction, and I have 3. My base is still stay the same, 3a and b. 3, though, has a new exponent. 1 times 3 is 3. A has a new exponent. 5 times 3 is 15. And then b has a new exponent. 3 times 3 is 9. But just so you understand on the homework, when you see a problem like this one, it actually wants you to, or it may in some cases want you to evaluate numeric bases like this. And 3 to the power of 3, you can put that in the calculator, but you're going to end up with 27 either way. So the final answer for this one is 27a to the power of 15 all over b to the power of 9. This is the one that we want. So that brings us back to the objective. So I guess the first part is you should be able to simplify expressions involving an exponent raised to another exponent. But in addition to that, you should be able to now combine the rules and the properties for exponents. And by the way, yeah, we've only gone over addition, subtraction, and multiplication of the exponents. In 9th grade, you'll go more in depth into division of exponents. We will not do that in 8th grade.